Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our special CoCoRaHS Weather Talk webinar on significant weather events of 2020. A very warm welcome to all of you joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from, it looks like partly cloudy Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we are recording today's talk, and it'll be available later this week on our website. All of our Weather Talk webinars are sponsored by generous donations from listeners just like you. Well, we're excited to have back with us our good friend, Greg Carbin. Greg is the Chief of Forecast Operations at NOAA's Weather Prediction Center in College Park, Maryland. Each year, Greg puts together a presentation on the top 10 weather events in the U.S. during the last 12 months. And Greg has given these talks to packed rooms at various weather meetings around the country. In fact, I've seen him several times. He does a great job. But it's been 5 years since we've had the privilege to have Greg give his talk here on Weather Talk webinars. And so we're sure glad to have him back with us today. Well, Greg, it's great to have you back with us after all these years. I'm going to start off by asking a question I've been asking a lot of our guests lately, and people are always curious. How did you get your start? What got you interested in weather? Was there an event sometime during your childhood, or maybe you could tell us about that?
Yeah, sure. Thanks for the invitation, Henry and Noah, for working on the technical details. So I've been with the Weather Service going on close to 29 years, I think, or 28 years. Before that, worked in the private sector. So over 30 years in meteorology operationally. Growing up in Vermont. So from about the age of 10, my father moved us up to Vermont when I was about 10 years old. And it was the winters, it was the winter storms, it was the days off of school that got me intrigued with meteorology and especially winter weather. And I'll never forget the blizzard of February 1978 really being a defining moment, watching 3 feet of snow and about 6 feet of snow on the ground. So it's still amazing and still interesting to watch. I wish I was in California today in the Sierra Nevada where they're picking up 10 feet of snow. I think that would be phenomenal to experience. But then since that point on, it's all types of weather, hazardous weather, severe weather, extreme rainfall. I've been interested in all these aspects for many years and continue to be, both fascinated and mystified by the atmosphere.
Boy, that sure is interesting. I remember that's 78. We were on Long Island at the time, and we got walloped with that as well, and folks, family in the Boston area too. So that's certainly a one in a lot of people's minds.
Indeed. And
all right. Well,
today. Yep.
We're going to let you take it away, and then we'll be back at the end to field a few questions for you.
Great. Let's see if I can share my screen here. Let's see. I am not getting a screen share.
Greg, if you might need to wiggle your mouse around and then you'll see some options pop up possibly on the bottom of your screen that says share screen.
There we go. All right, let's see. Let's share desktop 1. Can you see the screen? You're probably also seeing the tabs, right? We want to get rid of those if we can.
Well, it looks pretty good. Oh, now we're.
Let me try to hold on just a second here. Yep.
And I will say that Greg gets an excuse because the Commerce Department does not allow Zoom, and so Greg has to use a different computer to instead of a work computer, and they're not able to be used to using Zoom like many of us are. So you get the excuse, Greg.
And I still have trouble, and I have no excuse. So
it is interesting. I think we may have to live with tabs, but we'll see here just a second. If
yeah, and that's not the end of the world. I think that'll be fine.
There we go. I think I'm going to have it here. Let's see. I'm going to get back to Zoom. That's the challenge. I'm trying to go full screen on one screen, and I need to get back to the Zoom control. So give me just a minute here.
Well, we will let you know while we're waiting that coming up, our next Weather Talk webinar, for those of you who are interested, Amy Fritz from NOAA's co-op program is going to be talking on March 11th. And so you mark your calendars for that one. We'll have registration information up on that shortly. But the co-op program is NOAA's long-established citizen observation program, long before CoCoRaHS. In fact, many, many years they've been doing that. So we'll have that on our website for you guys to sign up. And Amy's a ball of fire, so she'll give a great presentation on that. Okay, here we go.
I think we're set. Very good.
Thank you.
Okay.
Take it away.
So, thanks again for the invitation. My pleasure to speak today to the CoCoRaHS webinar series here. These are some meteorological memories of 2020. When I put this talk together late last year in 2020, usually I do this around October, November, and I do it for the National Weather Association annual meeting. And then in December, I'll fill out the talk and come up with roughly 10 events. Just a few notes on this talk. These are my events. These are unique, interesting memories and events that I've experienced through the years. Your mileage may vary. Some of this information is not quite what you might expect for a meteorological event. You'll see that especially this year with one event in particular. I generally present them in chronological order. It's not an official ranking, so no wagering, I always say, but you can play along at home and try to guess what might come next in the order of events. So this will run about 30 minutes and we'll get underway here. So the first number one event for 2020, I titled, Where's Winter? Winter temperatures were well above average over most of the United States and much above average over the eastern US, the contiguous United States, that is. West Virginia and Rhode Island each had their fourth warmest December through February period on record into early 2020. And there were 22 additional states that had their top 10 warmest winters. So my question about where was winter is a bit of a trick question based on the map shown here, but more on that in a minute. During the second week of January 2020, it was quite memorable for a warm wave in the east. You know, normally in January in the east, expect to be a bit chilly, similar to the pattern we're in today, with well below normal temperatures starting to really spread across parts of the eastern United States. The American Meteorological Society held their annual meeting in Boston during the second week of the month. And it felt more like an early spring or even late spring in Boston for that week instead of the middle of winter. So just taking a look here at that mini winter weather heat wave that evolved across the eastern US, the loop that you're looking at shows the forecast minimum temperatures and the anomaly, that's the color fill, from January 10th through 14th. And you can see the minimum temperatures easily exceeding 25 degrees above normal for this time of year. The tables on the right show a daily high minimum temperature and daily high maximum temperatures. These are the number of observations that were broken, the daily observations that were broken for each day in both of those categories. And below that is kind of the mean difference of all these records. I basically took the mean of all of the differences from the prior record for that date. And so that's sort of what the tables on the right show. It gives us kind of a context for how unusual this heat wave was. And clearly, January 12th was the core of this warm winter period with more than 200 temperatures breaking records and 250 high maximum temperatures broken on that day, with an average difference of the prior record of 5 to 6 degrees. So pretty substantial, anomalously warm period of time for that day. Some of the more extreme records on January 11th and 12th included a 77-degree temperature in Marietta, Ohio, breaking the previous daily record by 19 degrees, and a 79-degree reading in Pulaski, Virginia the following day, and that broke the daily high temperature record at that location by 17 degrees. The period of record at both those places of 50 to 100 years. So a long period since they'd seen warm temperatures on that day in January. The 5-day period made up about 35% of all the recorded high minimum temperatures broken during the month of January, and almost half of the record high maximum temperatures were broken in this period for the whole month. And no state in the lower 48 ranked average or below average in temperature for the month of January 2020. As far as snowfall for the winter, this is an experimental departure map that I developed using the daily snowfall grids from NOAA's National Hydrologic Remote Sensing Center. Based on more than a decade of this digital snowfall data, this map shows the departure from October 2019 through April 2020. And for snow lovers, it was a depressing winter across much of the East, with the exception of a few spots across the interior Northeast. Again, it wasn't too bad where I grew up in Vermont. They had pretty much a normal snowfall season. But areas from I-95 corridor, even into the central Appalachians, saw snowfall departures in excess of 3 feet below normal. Aside from spotty locations across the Rockies, there was well above normal snowfall measured from the central and northern high plains to around Lake Superior. And the snowfall was well below normal across parts of California, especially the Cascades in Oregon and Washington. You can see the below normal values there for the season. So where was winter in 2020? It was in Alaska. While the contiguous United States had its 4th warmest winter on record, Alaska had its coldest winter in 21 years and one of the coldest Februaries on record. And the January high in Fairbanks averaged about 4 degrees, the lowest January average daily high on record. And heavy snow in the McGrath area pushed seasonal snowpack to more than twice the normal depth. So that's a summary of where was winter, memory number 1. So moving on to memory number 2, this is definitely right up CoCoRaHS' alley here. This was a February flip-flop. It was very wet in some areas and very dry in others. And in fact, the day on February 22nd, 2020, was one of the drier days in the digital precipitation data record that the National Weather Service maintains back to 2005. And the wettest single day in the month was the 7th of February. And simple pattern recognition showing the upper level jet stream pattern here on these two charts that meteorologists use to evaluate jet stream and disturbances in the flow can show you what a difference that pattern can make on precipitation. So on the left was the driest day in the month of February, and on the right, the wettest. So here was a Twitter poll I sent out in late February with an attempt to test crowdsourcing knowledge, trivial knowledge. Nonetheless, it was interesting that for the 24 hours ending early in the morning on February 22nd, I realized it was very dry, recorded at the 9th lowest amount of 24-hour mean precipitation over the contiguous United States based on the digital record. And this is the 2nd lowest amount for a February day after February 5th, 2009. So the poll I asked was for the driest 20 days in the digital record back to 2005. What month has the greatest number of driest days? Would you expect January to have driest days, February, October, or November? And again, these would be days in which you're not going to see much in the CoCoRaHS map. It'll be pretty much zeros coast to coast. And what month do you think over the contiguous United States has the most driest days back to 2005? So the survey said October and January were pretty much tied based on this poll with the most driest days on record. And the actual value is, here's the danger of crowdsourcing, it's actually November. That shows up most often in the list of 20 driest days, followed closely by January and then February and so on. So that was just a fun little poll for the month of October after, or the month of February coming after that very dry day. So we'll close it out here, memory number 2, with a review of February's precipitation anomaly for the month as a whole. Much above average to record wet conditions were present across the southeast during February, and flooding rainfall on multiple days caused landslides and severe damage to roads and other infrastructure. In Jackson, Mississippi, the Pearl River crested at its highest level since 1983, inundating many homes, and several other rivers across Alabama and Mississippi were near or above flood stage. Georgia ranked 3rd wettest for the month, and stations across the San Francisco Bay Area, on the other hand, had well below normal, setting records for the driest February on record. San Jose, Sacramento, Oakland, and many other stations received no precipitation during the month, setting their local records for the driest February. One other interesting aspect of February 2020, this was the 3rd February in a row where widespread heavy precipitation was measured across large areas of the Tennessee Valley and Mid-South. And I've outlined here the 10-inch or greater isohyet, the areas to see 10 inches or more during the month of February. And you can see 2020 in red, and 2019 in the magenta color there, and 2018 in blue. A lot of overlap in those areas. And the wettest February on record by this measure was 2019. So the last 3 Februaries, and here we go into another one coming up, we'll see if this trend continues across that area of the country during this time of the year. On to number 3. This is about the late night Tennessee tornado event that occurred in early March, and Nashville and other areas in Middle Tennessee were severely impacted by deadly nighttime tornadoes late on March 2nd and into early March 3rd. These were the deadliest tornadoes to strike Tennessee since the super outbreak of the 27th April 2011, very memorable event there, and the worst outbreak across Middle Tennessee since another Super Tuesday nighttime tornado event in early February 2008, also a memorable one for me. The EF3 Davidson, Wilson, Smith Counties tornado with a 60-mile path length is the longest track tornado across Middle Tennessee in the official database back to 1950, and the second longest path length in recorded history back into the 1800s. The Putnam County EF4 tornado was the deadliest single tornado in Tennessee, with 19 deaths, since the EF3 nighttime tornado of February 5th, 2008 killed 22. This March 2020 tornado event resulted in about $1 billion in property damage. And we're going to take a closer look here at the meteorological environment and how it changed rapidly during the late evening hours of March 2nd. And I'll give you a heads up here. It gets a little bit technical, but we'll try to work through it. So this is Middle Tennessee, situated beneath a very strong confluent mid-level jet with a powerful jet speed max heading right toward across central Mississippi, or across the Mississippi River Valley in early evening. The forecast uncertainty was quite high for this event. You know, this time of year is not particularly conducive to widespread damaging tornadoes. And at this time of night, it's also very difficult to get long track tornadoes. However, the instability on the sounding from Nashville was respectable for early March. And the mid-level lapse rates are already steep above a modestly moist low levels, a boundary layer in the atmosphere. And that lapse rate aloft would steepen further. A cooler air aloft would come in with the jet, steepen the lapse rates, increase the instability, and provide enough instability for robust storm updrafts as the night went along. And as the wind speeds increased, the shear increased and allowed these storms to organize quite effectively. And another source of low-level shear and the potential for tornadoes occurred with a warm front that was oriented basically northwest to southeast across Tennessee. The storms tended to track along that boundary and result in numerous tornado events. And let's see if I can start the loop here, and we'll watch this loop roll. And you can see the evolution of the long track supercells basically across Middle Tennessee here through the nighttime hours. Unfortunately, all the volatile ingredients came together in a recipe for a nighttime tornado disaster, and Nashville and other towns in Middle Tennessee just happened, unfortunately, to be in the bullseye. And Nashville seems particularly vulnerable to tornado tracks. The March 3rd track is shown in orange here, and the March 1933 track in green, and an April 1998 track in red. And on the right is a graphic I put together after the last Super Tuesday event in February of 2008. And there's been some work done by doctors Victor Gensini and Harold Brooks. They've analyzed a distinct increase in both environments supportive of tornadoes and tornado reports across this region in recent decades. And Tennessee has also led the nation in the number of fatalities from nighttime tornadoes. On to number 4, I titled this one, COVID Clears the Skies. And obviously this is a different meteorological memory from those in the past, but one that was quite interesting to look at. Despite the lockdown, I have really fond memories of nice days here in the Washington, D.C. area. Beautiful clear skies, very little in the way of traffic congestion in the area when everyone was locked down during the springtime months in 2020. Even living just outside of the DC area, it was just clear days with peaceful blue skies through April and May. And this was not uncommon across many other major metropolitan areas, and showing LA here in this picture before and after COVID, or during COVID, I should say. And it was astonishing to anyone who looks around and skyward regularly in any area, any metropolitan area. There are no planes, few cars, and the traffic noise was almost non-existent. Unfortunately, those living in the New York City area reported hearing sirens for weeks on end. And over the past 6 months, well, now we're going on 8, I think when I wrote these notes, it's past many months, almost a year now. All of us have had never before experiences that we'll remember for the rest of our lives. And let's take a closer look at how the lockdown cleared the air. So this is data from flight radar showing total aircraft tracked globally over the past few years, going back to 2016. And prior to the pandemic shutdown in early 2020, the year was on track to be another record year in air traffic. Until it wasn't. The decline was rapid and steep and truly stunning. And this, along with the precipitous decline in vehicular traffic, has led to numerous and interesting meteorological ramifications. Air quality was greatly improved. These charts highlight some of the differences. For the LA area, the dark green bar between March and April 2020 at the very bottom of the chart is a stark contrast to the long-term air quality at this location. Other than a few times in 2005 and 2006, the LA basin has not seen a continuous stretch of good quality air like we saw this past spring. Concentrations of nitrogen dioxide, the primary pollutant from combustible engine exhaust, fell across the globe as automobile and truck traffic dropped with the onset of the pandemic. The difference between 2019 and 2020 is evident there on the charts on the right across the eastern US domain. And there was a lot of discussion about how the loss of aircraft observations might impact weather prediction. Many aircraft observations get into the numerical models. And while there's still work to be done with the data, denial and accuracy of numerical models, here's an analysis from my colleague Keith Brill at WPC. On the left is the drop in aircraft observations by continent, and the scale is different because there's so many over the Western Hemisphere, but basically you see the very strong decline in aircraft observations globally. And the bottom line is already depicted in the first slide from flight radar. The aircraft observations fell off with the pandemic. On the right is a chart from Keith's analysis of the day 1 24-hour forecasts for half-inch precipitation or greater over the eastern 2/3 of the US. Keep in mind that the precipitation forecast skill drops off with the onset of the warm season. So the drop off in all years from 2009 to 2020 is to be expected as we move towards summer. However, 2020 is the dark black line and indicates that there was pretty good skill during the months of April and May when compared to the same months in other years. And one conclusion is perhaps that there's a lot of redundancy in aircraft data so that the loss of it makes little difference. And even during the shutdown, we still had commercial freight flights that were providing data to the model. Also, since flight level data is mostly in the upper atmosphere where there's little moisture and only weak diabatic effects causing rainfall, perhaps less upper air data is sufficient to specify initial conditions in the models anyway. Whatever the reason, the pandemic shutdown does not seem to have hurt the model performance when it comes to rainfall forecasts, at least during the late spring and early summer of 2020. So we're up to event number 5, getting into the summer months here. Hurricane Isaias was quite a memorable event, and we'll talk about that event here. As it approached the Carolina coastline late in the day on August 3rd, it intensified to a Category 1 hurricane before making landfall near Ocean Isle Beach in North Carolina just before midnight on August 4th. The storm then accelerated up the East Coast as a tropical storm before transitioning into an extratropical cyclone over Quebec on August 5th. Isaias brought a swath of generally 3 to 6 inch rainfall amounts from South Carolina, northeast across Delmarva into eastern Pennsylvania, parts of New Jersey, and New York. Maximum rainfall amounts appear to have approached 10 inches in 24 hours across parts of southeast Pennsylvania. So I became interested in comparing Isaias to Hurricane Irene only 9 years earlier, another I storm during the same month. So here's the comparison between the two August I storms and their respective rainfall patterns. Isaias in 2020 and Irene in 2011 on the right. Irene still holds a top spot for its extreme daily rainfall amounts over the eastern US. In late August 2011, Irene brought devastating flooding to parts of the Northeast. And after seeing these maps, I wondered about the size of the storm, its intensity and speed, as well as antecedent soil moisture. Those can all play important roles in how these tropical storm events can have an impact. Continuing the comparison here of the two I storms of August, it's clear that Isaias was Irene's much smaller brother. The loop is a comparison of the pressure field and moisture transport just above the surface. And the red is basically the moisture, the intensity of the moisture transport. And Irene tracked a bit slower, but along an almost identical path to what Isaias tracked from about Delaware Bay north to Vermont. And I happened to be in Vermont for Isaias, but not for Irene. And during Isaias, I had a rainy day picnic next to a peaceful stream in central Vermont shown in the upper right. And the picture was taken not far from where Irene wreaked havoc along many streams and rivers in Vermont only 9 years earlier. So quite a difference between these two I storms from August. So my neighbor Sheldon Cusselson graciously shared this slide with me to highlight the fact that Isaias was also a prolific tornado producer. In fact, it looks like this storm will probably have the most tornadoes associated with it during the 2020 season. A preliminary review suggests that the tropical storm may have spawned more than 50 tornadoes, and Sheldon's analysis with the precipitable water product on the left shows a drier layer of air possibly associated with steeper lapse rates and the potential for storms to maintain robust updrafts in strongly sheared environments. So it could have contributed here to the large number of tornadoes that were observed as the tropical storm moved inland and along the mid-Atlantic coastline. I'd like to thank Sheldon for his analysis and contribution to my meteorological memory number 5. Okay, on to number 6, the Great Iowa Derecho of 2020. Coming less than a week after the excitement of Isaias, destructive and widespread straight-line winds blew across central Iowa on August 10th. The storms responsible for this derecho traveled a little over 500 miles in 11 hours. And the roadway distance from Omaha to Chicago is about 470 miles. The derecho covered this distance in about 7 hours, about the same time Google Maps will give you for an estimate if you were traveling at highway speeds around 70 miles an hour. The official highest wind gust was 99 miles an hour in Marshalltown, Iowa, with an unofficial wind gust of 106 miles an hour in LeGrand, just east of Marshalltown. And accurate predictions ahead of this significant and intense damaging wind event were a challenge. SPC double, then triple upgraded the day one severe weather outlook on this day. And that's pretty rare and points to the subtleties of this particular severe weather event. I'll go over some of the meteorology like I did for the Tennessee tornado event here. But first, these loops, while not synchronized, to give you an idea of the radar evolution and also the damaging winds resulting in a swath of widespread power outages as the storms raged east. The raw storm reports from SPC on this day indicate that August 10th holds the second highest daily total for all types of severe weather reports in a single day in 2020. Here's a loop of the Storm Prediction Center's mesoanalysis data centered on 7 hours when the derecho was at its most intense across Iowa into northwest Illinois. And the low amplitude shortwave trough, the disturbance in the mid-levels responsible for ascent along the eastward moving thunderstorm line is evident on the left. But there's nothing particularly outstanding about the magnitude of the mid-level flow, about 40 to 50 knots. However, the development of over 3,000 joules per kilogram mean layer CAPE, or instability, ahead of the convective line is certainly impressive. And if you have a chance to look at the Omaha sounding from this morning, it is quite an impressive sounding. It shows what we call an elevated mixed layer, where lapse rates are very steep, and any parcels becoming buoyant in that atmosphere can move up very quickly vertically, up to 100 miles an hour vertical wind speed within the thunderstorm updrafts. So this is one of those cases where the wind and the thermodynamic ingredients came together with just the right magnitudes and timing to support a rare and incredibly intense mesoscale convective wind event. It subsequently grew upscale to be an impressive subsynoptic convective swirl a little over 12 hours later over Lake Michigan. And there you go. That's the radar beauty in this beast for memory number 6. On to memory number 7, Hurricane Laura. Laura, a deadly and damaging Category 4 hurricane, came roaring ashore in Cameron, Louisiana, just after midnight on Thursday, August 27th. As seen here, the hurricane made quick work of destroying the NWS radar in Lake Charles, Louisiana, which just recently came back online. Laura was the 10th strongest U.S. landfalling hurricane by wind speed on record, and tied the 1856 last inland hurricane as the strongest hurricane to make landfall in the Louisiana coast. Laura was the earliest 12th named storm on record in the North Atlantic Basin, and the first major hurricane of an incredibly active 2020 tropical season. Damages and losses from Laura are still being compiled, but clearly will be significant. And here's a before and after shot of a drilling platform supply depot south of Cameron, Louisiana, showing a partially sunken vessel and a submerged dock area. In fact, the image on the right was taken as part of a NOAA emergency response about 3 days after landfall, so it appears the waterline is still well inland and covering significant portions of the town of Cameron, Louisiana at this time. Fortunately, Laura came ashore in a less densely populated area, and that was likely one factor that played into relatively lower fatalities with this significant hurricane. And those fatalities and damages may have been much higher had it come ashore a little farther east toward New Orleans or west toward Houston. You see here, despite the fatality figures, about 24 people are reported to have perished in Louisiana, and much damage, including falling trees, across parts of inland across Louisiana. Laura's track forecast was exceptional. The center of the official 5-day track forecast was about 2 miles from where the eye made landfall, and the 3.5-day forecast was less than a mile off. Incredibly accurate forecasts. The official intensity forecast, on the other hand, was lower than what was observed at landfall. The 60-hour forecast intensity for Laura showed a strong Category 2 hurricane at landfall. And intensity forecasting remains a very challenging area, especially when it comes to rapid intensification of these storms as they approach land. On to memory number 8. How about Western heat, fire, and smoke? Here's a look at the explosive creek fire that occurred south of Lake Tahoe in California, Sierra Nevada on September 6th. But this memory number 8 is more than a single fire, as incredible as this appears. And it appears as we continue to see, there were many fires and record-breaking heat even beyond this period of time here. And there wasn't much to help with extinguishing these fires, even as we moved late into 2020. So we'll take a look at the hot conditions and the dry conditions, as well as the wildfire conditions for memory number 8. The summer of 2020 is now shaping up to be the hottest, definitely the driest on record for parts of California, Arizona, and southern Nevada. And the map on the left depicts the average maximum temperature rankings for the summer months of June, July, and August. And on the right is the precipitation ranking for the summer, number 1 being the hottest and or driest summer. A 1 with an asterisk means this summer is tied for first place. For many places like Bishop and Needles, California, Las Vegas, Yuma, there had been no precipitation measured at these locations for months. At last count, Vegas has reached at least 100 degrees on 61 days in 2020. Yuma and Phoenix have reached at least 110 degrees on a dozen days. And let's not forget the 130-degree record high temperature at Death Valley on August 16th. Perhaps even more stunning is that the low temperature in Death Valley failed to fall below 100 degrees on 4 mornings during the month of August. And then there's the smoke associated with the fires. Here's a loop of the vertically integrated smoke, numerical modeling of the smoke, but at analysis time for the period August 15th through September 2nd. And it's clear to see the onset of some of the largest conflagrations get started in the dominant anticyclone that was contributing to extreme heat across the tinder dry west. As the month goes along, the western ridge is eventually suppressed southward, but a number of shortwave disturbances in northwesterly flow managed to transport that smoke eastward. And there's considerable smoke over much of the contiguous United States around August 25th. And then it dissipates and ends with a strong offshore flow in Northern California and parts of Oregon on September 2nd. According to NOAA's Office of Satellite and Product Operations, the 2020 fire season in California was the most intense in the 18-year record of satellite-derived fire radiative power transfer data. This includes 3 of the largest 4 wildfires on record that have occurred in the past in the end of the fire season. And the story of Western heat and fire is still evolving and being evaluated, but these events already deserve mention as meteorological memory number 8 for 2020. So let's move on here. These are the events that I filled in at the very end of 2020 here. And we can see the 2020 Atlantic hurricane season was most active and the 7th costliest Atlantic hurricane season on record. In addition, it was the 5th consecutive above average Atlantic hurricane season from 2016 onward. The season featured a total of 31 tropical cyclones, all but one of which became a named storm. Of the 30 named storms, 13 developed into hurricanes, 6 further intensified into major hurricanes, and 1, Hurricane Iota, attaining Category 5 strength on the Saffir-Simpson scale. It was the 2nd season to use the Greek letter storm naming system, the first being in 2005. Of the 30 named storms, 12 made landfall in the contiguous United States, breaking the record of 9 set in 1916. The season was also the 5th consecutive season in which at least 1 Category 5 hurricane formed. And during the season, 27 tropical storms established a new record for the earliest formation by storm number. This season also featured a record 10 tropical cyclones that underwent rapid intensification, tying with 1995. This unprecedented activity was fueled by a La Nina that developed in the summer months of 2020. And this just shows you the timeline here. The black boxes essentially around Isaias and Laura highlight those storms that I spoke of in more detail. And then the other boxes are those that made landfall after that time. And here's a look at the precipitation patterns that we observed with the late season storms from September through November. The precipitation is something the Weather Prediction Center specializes in. And this is a look at the observed amounts occurring with those storms right around landfall. And then at the very bottom of basically the 5-day track forecasts, giving you some idea of where the precipitation occurred within the uncertainty cone. And finally, number 10, I got my nor'easter in. If I waited long enough, this is a great time lapse here from December 16th through 17th near Binghamton, New York, showing the onset of an impressive band of snowfall that occurred over a relatively short period of 12 to 18 hours. This nor'easter didn't really intensify all that much, but moved rather slowly from the Delmarva region up into the New England coastal waters. And conditions were just ideal for incredible snowfall rates of about 4 inches an hour, basically from north central Pennsylvania across parts of the southern tier of New York and into southern Vermont, where 40 inches of snow was observed with this event. Just a really amazing event occurring over about a day and a half before the storm moved off into the Gulf of Maine, one that won't be forgotten for quite some time in these areas. So we'll watch that loop one more time and then we'll wrap it up here. And some of those spots in the Sierra probably seeing snowfall like this over the last day too. And there's a summary of some of the snowfall records here. Maximum of 44 inches in parts of New York. Potential 24-hour Pennsylvania state record of 43 inches. Potential 24-hour Vermont state record of 42. Two-day snowfall record of Binghamton with 39 inches. A two-day snowfall record in Williamsport at about 25 inches. The 8th largest snowstorm on record at Albany, New York. Just an amazing event. And a very focused, intense snow band associated with this snowstorm. So there you have it, the top 10 meteorological memories of 2020. Thanks again for having me at the CoCoRaHS webinar talk here. And I guess we have maybe a few minutes for some questions.
Yeah, thank you very much, Greg. Very, very interesting to see all these different events. I've forgotten some of them. Us folks here in Fort Collins definitely remember the smoke. We had some really intense close by fires in September and October. In fact, I remember middle of the day, street lights coming on, the smoke was so thick.
Wow. Yeah.
And ash covering the cars and so forth. So something like that we hadn't seen in quite a while in this area. But yeah, active stuff, boy, indeed. We're going to take some questions if you have a few minutes here.
Sure.
And we'll see if we've got them coming in. If you want to just type your question in, and we'll pass them on to Greg. So we'll give it a minute or two. If you would put your state and your name on that, that would be great. So, and maybe there aren't any questions, but. So when you were up in Vermont, I guess when that storm came through, you were on vacation at that time, and luckily luckily it wasn't like the storm earlier on in the decade.
Yeah, it was hard to take that leave. I'd had leave, and we saw Isaias coming, and I was troubled by being away from work during that event. But as it approached, it looked like it was probably going to move pretty quick. Rainfall, while problematic in some areas, wouldn't be hopefully too significant, and just happened to be up in Vermont for that. It was very little impact from that event. Of course, they started out drier this year, and they still continue to be dry up in parts of the Northeast. So it ended up being not a problem. And that when I got back and I did that comparison with Irene, I saw how dramatic the differences were between the two storms.
Okay, we got a couple questions. So let me jump to those real quick. Melissa, in South Carolina, was wondering if there are any other events that stand out to you from 2020 that didn't make your top 10. So were there others in the back of your mind on there?
That's a great question, Melissa. It's hard to fit. There's more than enough content in just about any year. And like I said, I usually don't start putting this together. I don't start feeling the pressure until August, September timeframe. And then I'll go through and look at what are some of the things that caught my attention, either on Twitter, maybe I put a tweet out, maybe I did some analysis on a particular event. And to be honest, 2020 was so dramatic anyway, and for so many of us in terms of the COVID situation and working remotely. I think, I could have spent a lot more time going through and looking at the tropical cyclone events that occurred and the remarkable intensity of those events and frequency of those events, because WPC, we're on the spot for coming up with the rainfall forecasts ahead of those. I'm trying to think if there's anything else that may have been there on the list. I'm sure there is, but I'm already beyond 2020, to be honest. We're already filled up with what's coming up over the next week. So you can only look back for so long, and then you've got to look forward. I know, as far as this season goes, we already probably have this California event will most likely be in the 2021 memories. I can say that's underway right now, but there's some really remarkable rainfall and snowfall with that. So we got at least the first one for 2021.
So if you're out there in California in the Sierra Nevadas and you're a CoCoRaHS volunteer, make sure you get your gauge out, have your gauge out, and take those snow measurements as well. We'd love to see them. Okay, here's one here. Nora from Florida was wondering, would you consider 2020 one of the most extreme years? Or if not, is there another year that you would consider?
Well, it depends on how you define extreme.
Yeah.
What's interesting, precipitation-wise, it was not. If you take the year as a whole in terms of precipitation, which we track fairly accurately, and again, thanks to CoCoRaHS across the contiguous United States, it wasn't one of the wetter years on record, I believe. But you don't have to go too far back. I think 2019 actually may have been one of the wettest, if not the wettest, in the modern record as far as total precipitation. So it was interesting from that perspective that many months did not continue the trend that I've been tracking in recent years to be wetter than normal. And that's even more surprising when you consider the frequency and occurrence of tropical cyclones, because they contribute tremendously to heavy rainfall. So it was rather unremarkable in summary for precipitation. The derecho in Iowa, that was a high end event, and that was a very unique. It's not that we don't get them, and that is really the area you would expect to get them, but its intensity, I think, caught everyone by surprise. That was really remarkable. And then, of course, the extreme fire weather conditions in the West. So while some events you could certainly characterize, or some categories you can characterize as extreme, other categories were not as extreme. But I would say heat, fire, and tropical cyclone activity were all quite extreme in 2020.
So Jack and a few others wanted to know if many of these events did climate change contribute to those, in your
Well,
opinion?
I think NASA has just come out in the last week or two categorizing 2020 as the warmest year on record, or tied as one of the warmest globally. Winter again in the East was almost non-existent. That's certainly a global warming signal. And again, even though the precipitation didn't rise to being a record when taken in aggregate over the year, or even up by month, it's not that far off, right? So the one year does not make a trend, but there have been many years that we've seen recently where the warmer season months, June, July, August, have really remarkable, widespread, heavy precipitation events associated with them. 2020 just happened to not be one of those. And so there's this balance, and we've heard this for quite some time from folks looking into climate signals and climate change signals, that what we will see is more likely dramatic swings from one extreme to the other, from drought to flood, from heat to cold. Even though it doesn't seem that makes a lot of sense in a warmer world, it does seem to occur with a warmer climate, that you see these dramatic changes from one regime to the other. For me, I think one of the really interesting takeaways from this year, while COVID-19 is certainly a very unfortunate event, and the global pandemic has had a dramatic impact on people's lives and livelihoods, it indicates to us how quickly the climate can change, and how quickly we can sort of clean up the air when not using combustible fossil fuel on such a large scale basis. And so, memory number 4 is really a standout for me, and how quickly the atmosphere can change and even recover in the absence of mankind's activity.
Okay, here's one from Janice in Colorado, and I think this is right up your alley. She said, "Did the warm season affect the maple syrup industry?" And what's your thoughts on that?
From what I know, and I know a few folks that are in the industry up there, they had a remarkable season, a very productive season. I think that we are seeing the sap begin to flow earlier in recent years than in the past. In fact, some of the producers are usually getting well underway in February. When I was growing up, that was unheard of. It was very unusual that you would start sugaring in Vermont prior to March. So what seems to be happening is they're getting a start a little bit earlier. And the other thing that is interesting in recent years is that they've held on to the colder air a little longer. There've been a couple of unusually cold March months in the Northeast in recent years. So while they see this tendency to meet the right conditions for the sap to flow, they're also holding on to that sap flow a little longer before the trees bud out, and that pretty much shuts it down. So my understanding is the last couple of years have been going boom up there for maple syrup production, and hopefully that keeps up for a while. You got to wonder though, with a warmer climate, if they can maintain the ideal conditions for any significant length of time before they start to see a change.
Thanks. Here's one from Sean, and this is an interesting question. Do you have any more insights into the impact that aircraft observation count reduction has on future computer forecast model development? The loss of observations having nearly no impact on forecast accuracy seems fascinating. Do you think this merits further research?
Yes, and I'll bet you that research is going on. It's not that the data don't provide some insight, and I know that the aircraft data are pretty important for real-time monitoring of the atmosphere at local locations, at busier hubs. I do think, though, that what we're seeing is an increase in the ability of satellite data to replace the aircraft data. So it's only been a few years where we've seen some really remarkable advances in geostationary satellites, a lot of polar orbiting satellite data too, that's being ingested into the global models. And the quality and the resolution of that satellite data has increased in recent years to the point where it's probably compensating for the drop in the aircraft observations. So the aircraft are going to keep flying, and they're still very viable observation platforms, and their data will still be important to numerical modeling. But with the advances that have been made in satellite, I think that's why we're not seeing a dramatic decrease in skill. And again, that's not the final word either. I think there may be other ways of looking at numerical model accuracy, and we may yet find that aircraft data play an important role.
Great. Thank you. Here's one from David in North Carolina, and he was referring to the derecho that occurred this summer. How often do these occur, and just how unpredictable are they? And I'm going to add to that, is there a preferred region of the country where these occur? I know we had one in Colorado in 2020. I think it was 2020.
In the Mid-Atlantic region, and had one in 2012, I believe it was. There is a corridor of favored conditions. So these are not uncommon, especially as you move into June, July, August, the warm season months. And there is a preferred corridor of greater activity for these events. It basically stretches from the northern plains, upper Mississippi Valley, east-southeastward across the Corn Belt into the Appalachians and into the east. There's been some great work done by this. Former Storm Prediction Center meteorologist Bob Johns. Actually, I think Bob is responsible for coming up with the phrase derecho. And the Storm Prediction Center website has some really great work done on derecho climatology and frequency of occurrence. The reason that they appear when they do and where they do is because you can get very hot conditions over the elevated terrain of the western US, the Intermountain region, and even the Mexican escarpment. These elevated terrain areas heat up very well during the summer months, and that heated air that's above the surface will then spread out east across the plains into the Midwest. And when you combine that with the very warm and moist low levels in the atmosphere, things like what we call evapotranspiration from the corn belt and other forms of vegetation, contribute to extreme instability. And so what you really need to get these things moving and also producing the wind speeds that they produce is high instability in the atmosphere. And that's what you saw in the case of the Iowa event. But there's a lot of subtlety with these too, and the right balance of these ingredients is required to get the system sort of to bootstrap itself into greater organization and take on the form of that bow echo that rages on well to the east at 50 to 80 miles an hour. So there's been a lot of work on this. Some are easier to predict than others. But they all have these subtleties with respect to the mix of the ingredients that it takes to get the atmosphere to do that.
Greg, with those, is there much tornado activity, or is there, and the other question is, are there's a lot of thunder and lightning with that, or
There's
lightning with
tremendous
those?
amounts of electrical activity with these. Again, given the instability, again, the updraft speeds anywhere from 70 to over 100 miles an hour in thunderstorm updrafts. So what that allows you to do is basically spread precipitation in its various forms and keep it aloft. So you'll have hail mixed with liquid precip, and it's the differences in the precipitation within the core of the thunderstorm that create the charge difference for lightning. So lightning is easily very active in these events, and tornadoes as well. So again, you're dealing with a very turbulent environment, and there's a tremendous amount of vertical shear. Usually it's not quite the vertical shear that we look for tornadic, what we call tornadic supercells. And these events tend to merge. These supercells will merge and be forced along the outflow. And the outflow, again, becomes sort of a conglomerate of all these individual cells. And the more linear that feature is, the more likely you're just going to have straight line winds. I shouldn't say just, because they can be just as damaging as tornadoes. But before that linearity appears in these systems, as storms remain discrete, and even along the line, you can have spin-ups and tornado events, some of them quite small, but those would be areas where the wind speeds would be quite a bit more enhanced, anywhere, 100 to over 150 miles an hour in those brief spin-ups.
And, this might be a really good topic for a future CoCoRaHS webinar, and maybe I can talk to you offline who might be a good person to
Sure.
present something like that. So if you folks are interested in that out there, maybe we can get one of those in on this event or these events this season. Okay, let's go to a couple more questions. Now we're getting to the top of the hour, so we're not going to be able to answer all of these. Greg, if possible, would it be possible if you could follow up with some folks
Sure.
on some of their
Sure.
questions afterwards offline?
Yep.
And so here's one. Hans in California was wondering, you mentioned La Nina having an impact on the hurricane season. Could you explain what that is, why that is?
The general understanding of the La Nina, which is part of what's called the El Nino Southern Oscillation, which is linked to a cyclical pattern in the Pacific of sea surface temperature. A La Nina is typically cooler than normal sea surface temperatures in the Pacific Ocean, in a large belt near the equator. And that anomaly in sea surface temperature causes a change in the atmospheric flow across the northern hemisphere. La Nina, the flow regime changes so that there's less wind shear over the Atlantic basin during the warm months, during the tropical season. And that makes an impact on the ability for nascent thunderstorms to begin to organize into cyclonic circulations and become tropical cyclones. The stronger the wind shear over the Atlantic basin, the less tropical cyclone activity. And there's a very strong correlation between wind shear and the ability of hurricanes to form. So La Nina is basically a favorable pattern for less wind shear over the Atlantic, and therefore more potential for tropical cyclone formation.
Thanks. Here's one from our good friend Tommy in Staunton, Virginia. And he was wondering, with the Weather Service, the radar getting decimated there in Lake Charles, are they able to bring in a mobile radar system while that radar is down? Is there any, the hurricane's coming, this could happen. I know the Doppler on wheels and stuff like that is out there. Is this something that can be is used during these storms?
That's a great question. I'm not aware that they did that in this case. However, there is redundant coverage to some extent in that part of the country. So I think it's The Shreveport area has a radar. New Orleans has a radar. Houston has a radar. So it wasn't as if there was a complete lack of radar coverage in that area. It did degrade perhaps the radar ability, but when you look at radar systems across the country, as I do, I often look at composites of those, mosaics of those radars, not just single radar sites. But that is a very good question about portable radars. I would think, in the wake of that event, though, many people were really struggling, even just getting power back. And one of the bigger challenges they also faced in the wake of Laura was very warm and uncomfortable conditions. So the Weather Service actually lowered the criteria to issue heat advisories and heat warnings because they were concerned the lack of power, that people would try to do too much work and that be very detrimental to their health. So I think a lot of folks were trying to just get back to some semblance of normal there. And the radar was a priority, and it was eventually repaired, but that did take some time.
Okay, well, thank you for that question. We're going to end on the last one here. Richard wanted to know about how CoCoRaHS data has improved observations in rain and snowfall in the U.S. And I want to ask you too, Greg, you being the chief of forecast operations there at the Weather Prediction Center, letting our folks know out there, how important are their observations, and do you guys use them? And, somebody's probably thinking, well, I just report every day. Is my stuff looked at? Does it make an impact? So how does it help you guys?
Well, I'm a CoCoRaHS observer too, and I do it because I enjoy the science of observation. Observations are key to meteorology, and it really starts with an observation of the current atmosphere. We diagnose the atmosphere before we can prognose or forecast the future state. So any and all observations are important, and high quality observations are especially important. And so your rainfall and snowfall observations are used, actually. We are responsible for compiling storm summaries for major events and also reviewing significant rainfall events to learn from them and to improve the forecast process. So CoCoRaHS is a tried and true network of observations that the forecasters, meteorologists at the Weather Prediction Center rely on to assess recent events and understand their magnitude, and also basically to maintain a record. The longer the record, the better, so we can begin to detect trends and changes in climate as well. So appreciate all that the folks are doing out there, and the CoCoRaHS program is great. Really love the new map this year where you can zoom in and do different ranges. So so really useful information, and thanks everybody for participating.
Yeah, we really thank you guys out there for your observations. They're really helpful, and they are used. So there you go. There you have it. Well, we're going to wind it up for today. And if your question wasn't answered, we're going to pass those on to Greg the next week or so, or when he has time. He's a very busy guy, but he'll hopefully be able to answer some of those for you. And Greg, always a pleasure to have you as part of our program. And hopefully we can do this again in the future as the years go by. So thank you very much.
Thank you. It was a pleasure.
Well, folks, please join us for our next CoCoRaHS webinar, as mentioned earlier. That'll be on March 11th at 1 p.m. Eastern Standard Time. It's actually Eastern Daylight Time by then. And Amy Fritz from NOAA's National Weather Service will speak on the COOP program, which is NOAA's long-established citizen observation program. And a very interesting talk. I think you guys will enjoy that. Finally, when signing off today, please take that brief survey that'll pop up on your screen. Just ask you to do that. And so until next time, this is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now and have a great afternoon.